Okay, so in this video, we're going to tackle the question around apparent weight. So apparent weight is defined as the apparent gain or loss of weight based on the acceleration of an object in a vertically moving vehicle. Okay, so the word apparent means you don't actually gain or lose the weight. It just seems like you do, right? It appears to change your weight. Okay. Most of the times the moving vehicle will be, or they're going to be elevators, okay? And specifically, if you go to a high-rise building, right? Maybe not so much the one here on campus, right, here in RHS, but typically there'll be high-rise ones that have to get you to like the 80th floor quickly. But it's going to be really anything that looks like that. And then sometimes you could be lifting something as well. So, you put a fish on a spring scale and you can lift it up, okay? You're going to see that the spring scale is going to change based on your acceleration. But generally, your free body diagram will look the same in every situation, okay? You're going to have the apparent weight up and then the actual weight down. And so this little prime notation, right, it's like a little apostrophe, that means apparent, okay? If you remember when you did transformations in geometry, if you move the triangle, if you did a transformation, you did a translation, right? You would say like triangle A, B, C, right? And then you're going to turn that into triangle A prime, B prime, C prime, okay? But typically, right, this is going to be all of our draw steps. So it's going to be apparent weight up, weight down. And then when you solve your equation, or when you do the sum step, it's always going to look something like this. Fg prime minus Fg equals ma, which once you get to this point, the Fg prime minus Fg equals ma, you can solve for anything that you need, right? You can solve for the acceleration, or typically you're going to solve for the Fg prime, okay? And so by me doing this, I've done the first two steps, and I'm just going to kind of skip those steps in the problems, okay, that we're going to go over, and so that we can just move forward and get to the next video, okay? So this example says a person's mass is 50 kilograms. What is their apparent weight when riding in an elevator under the following conditions, right? So going up with a constant speed of 9.8 meters per second, going down with a constant speed of 9.8 meters per second, and then accelerating up at a rate of 9.8 meters per second squared and accelerating down at a rate of 9.8 meters per second squared, okay? So let me split my page here into 4 problems, right? Because we have A, B, C, and D. So A, B, C, and D, right? I will tell you this, A and B are going to be the same answer, right? Here's why. That phrase constant speed means there's going to be no acceleration. So I would do my, right, first steps will be draw, right, sum. And now what I'm going to do in the actual workspace is do the solve step, okay? So all my workspaces here are going to be the solve step. And so on here, I have my sum, so I have Fg prime minus Fg equals m times a. But constant speed means a equals 0. So really it's Fg prime minus Fg equals 0, which tells me that Fg prime equals Fg. And remember, Fg has a formula of mg, and so that's going to be 50 times 9.8. You can actually use 10 here, but I'm going to use 9.8 for a reason. And so it's going to be 490 newtons. And really the reason I'm doing it is for part C and D. Okay? Now, I'm going to be lazy. B is the same solution as part A, right? Because it doesn't matter which way you're going when you have constant speed. Okay? Remember, constant speed means acceleration equals 0. which means when you sum it, you're going to set it equal to 0, and it's just the same thing throughout. Okay. In fact, maybe I can. I don't know if it was just going to be like one thing. Yeah, it's only going to give me one thing there. Okay. I was hoping that I could maybe do a whole selection and just kind of copy and paste into the other section. Okay, into part B. All right, part C. All right, we're going to accelerate up at a rate of 9.8 meters per second squared. So again, we're here after what I did right above. So we're at fg prime minus fg equals ma. Now what we're going to do is our acceleration, remember, is a vector, so we have to put in the sign. And when we accelerate up, really accelerate up here means in the same direction as your velocity, right? So the velocity and the acceleration will work together, right? And so I'm going to do fg prime equals fg plus ma. But remember, fg has a formula of mg. Okay, so we're going to do mg plus ma. And so I'm just going to do a little bit of algebra here. I'm going to pull out theta m. And so it's going to be g plus a. And if I'm plugging it in a positive, what you're going to see is this number here, the g plus a, is our acceleration. It's going to be bigger. Right? And so now I'm going to plug in my actual number. So I have a mass of 50. My g, my free fall acceleration is 9.8. My acceleration is 9.8, right? It's from over in our scenario over there, right? And what you actually see when you go at the same free fall rate or the acceleration as the free fall, you're going to see that you're going to be double your weight. Okay, you're going to be double your actual weight. So our apparent weight would be 980. Not meters per second squared, sorry, it'd be newtons, right? Because force is measured in newtons, okay? So our apparent weight, if we're going at the same free fall acceleration, would be 980 newtons, right? So if I'm accelerating in the same direction as my velocity, I'm going to feel heavier. It's going to push down on me more, okay? And now if we do our next one, right, the solving is actually the same. The only difference is at this point, or when we plug in A, we're going to plug it in as negative A, okay? Because we're going opposite. So it's going to be fg prime equals fg plus ma, right? Fg prime is mg plus ma. Fg prime is m times g plus a, right? And as I said up here, for A, we're going to plug in negative. So we're going to do fg prime equals 50 times 9.8 minus 9.8. Well, that's easy. 9.8 minus 9.8 is 0, which makes my apparent weight 0 newtons. So if I accelerate opposite my direction, right, I'm going to feel weightless, okay? If I go at the same rate, okay? And so when we talk about upward and downward or up and down in this situation, we're talking about in the opposite or in the same direction as the velocity, okay? Next question says, as a part of a physics experiment, you stand on a bathroom scale in an elevator. Though your normal weight is 610 newtons, so our Fg, right, is 610 newtons. Okay, the scale reads, we're in the elevator, it reads 730 newtons. Okay, part A is the acceleration of the elevator at this moment, upward, downward, or 0, and explain. B, calculate the magnitude of the elevator's acceleration. And C, what, if anything, can you say about the velocity of the elevator? Okay, so part A, if you just think about what we did in the previous example, you know, when we talk about up or down, right, we're saying the acceleration and V are in the same direction, right? So it's like positive A, positive V, negative A, negative V, right? Same direction. And downward would be positive A, negative V, or negative A, positive V, right? Opposite each other. So in the first scenario, right, the upward scenario, and then 0 would be if, you know, we're just saying we're not accelerating, okay? But if you remember from the previous example, we know that's not true because if we weren't accelerating, our weights would be the same. Our apparent weight would equal our actual weight. And then in C, we're accelerating up, so they're in the same direction, okay? And part D, they're in opposite directions, right? So they're accelerating downward, okay? So by looking at our numbers in comparison, if our apparent weight is more than our actual weight, we are accelerating upward. And what's our justification? Fg prime is greater than Fg, okay? Now, if this is the test, you want to write out a little bit more. You would say the acceleration of the elevator is upward at the moment because our apparent weight is greater than our actual weight, all right? So part B now says, what is the magnitude of the elevator's acceleration, right? So just like we did before, sum the forces, Fg equals ma, or Fg prime minus Fg equals ma. And so we're going to solve this for Fg, or for A. But the thing is, we need to know what mass is. So, I mean, it's a simple calculation. So remember, weight is mg. That makes mass Fg over g, right? F sub g over g. So 610 is our actual weight divided by 10, right? So 61 kilograms. It's a little bit less because 9.8 is a little bit less. And so acceleration of the Fg prime minus Fg over the mass, okay? And so we're going to do 730 minus 610 divided by 61, and that's going to give us our acceleration. We know it's going to be positive because Fg prime was bigger, and so the magnitude is 1.96 meters per second for our acceleration, okay? Part C, what, if anything, can you say about the velocity of the elevator? Because we said the acceleration was upward and our acceleration ended up being a positive number, we would say the velocity, right, and the acceleration go in the same direction. Now, we can't say if it's up or if it's down. We would need a little bit more info, but we just know they go in the same direction, right? Because we're, and you know, kind of what's our proof? Fg prime is greater than Fg, okay? So that, I mean, that'd be something along the lines of what you may see on a free response question, okay? Especially with the writing aspect that they want to include now. But the next set of videos, I'm going to break them up. I'm going to kind of scroll up a little bit. Okay, we're going to talk about surfaces and surfaces that move against each other, and this is where we're going to introduce in friction. Okay, but we'll build our way up to bringing in that full surface, but we'll also do inclined planes in this next video, or actually it's going to be in this next set of videos. Okay, because I'm not going to do this. Would be one giant video if I decided to do it as a single video.